Hello students, I am Dr. Navneet Kaur, Associate Professor in Department of Electronics and Communication Engineering, Sagar Institute of Research and Technology College. This college comes under the SAGE group. Today I'll be taking the first lecture of the subject Digital Signal Processing. In this lecture, I'll be taking the introduction of the subject. Now first, we'll start with the scheme of the semester 6th. Now, in this semester, we have digital signal processing whose subject code is EC601. Here we have both theory and practical exam. The theory end exam is consisting of 70 marks, mid-sem exam is of 20 marks, and quiz or assignment covers 10 marks. In practical domain, we have end sem as 30 marks and lab work consists of 20 marks. Now, this is the syllabus of the subject, digital signal processing. In unit 1, we will be talking about different types of discrete time signals and systems. In unit 2, we'll be taking the frequency domain representation of discrete time signal, which will be in the form of the Z transform. In unit 3, we'll be taking the frequency analysis of discrete time signals, which will be covered by discrete Fourier series and discrete Fourier transform. Now in unit 4, we will be considering FFT algorithms, which are fast Fourier algorithms, which are the fastest method of computing the Fourier transform of discrete time signals. And in unit 5, we'll be taking the designing of the digital filters like IIR and FIR filters. Here we have given the books which will be referred for this subject. Now, these are the course outcomes of this subject. Now, the course outcome of this subject is covered by using 4 skills. First is the understanding, second is the applying, then analyzing, and then we have evaluating. CO1 will cover all the content of the syllabus, which will be covered by the skill understanding. CO2 will be pertaining to skill applying. Then CO3 will cover analyzing skill and CO4 will cover evaluating skill. Now, first we will start with the concept of the signal. Now, what is signal? Signal is any physical phenomenon that conveys information from one place to other and represents as a function of independent variables such as time, temperature, distance, position. Here in this diagram, we can see a time-dependent signal. Here along the x-axis, we have shown the time parameter, and we can see that this signal, it changes its amplitude as it travels along the time axis. Now, signals are represented as functions of one or more independent variables such as time, distance, position, temperature, pressure, etc. Basically, the signals are of 2 types. First is continuous time signal and second one is discrete time signal. The basic signals which we cover are continuous time signals like sinusoidal signal and exponential signal. These all signals are continuous time signals. Now, discrete time signals are obtained when we sample a continuous time signal. These signals can also be generated directly by some discrete time process. Now, here we can see the different types of signal. Now, first is the continuous time and continuous amplitude signal. Here we can see that the signal has a value at each and every instant of time. Therefore, it is continuous in time. Also, the signal can take any value along the y-axis. Now, the second is the continuous time and discrete amplitude. Here we can see the signal is continuous in time because it is defined at every instant of time, but it is discrete in amplitude because it has only two values. First is the positive level plus L and second one is the negative level minus L. Other than these two levels, all other values of the amplitude of these signal is not possible. Now, third one is discrete time and continuous amplitude. Now, this signal is discrete in time because it is defined at discrete instance of time. It is defined at, say, at n is equal to 0, at n is equal to 1, at n is equal to 2 and 3 and so on. That is, it is defined at discrete values of n. It can also be defined at n is equal to minus 1, n is equal to minus 2 and so on. But it is continuous in amplitude because along the y-axis, it can take many values. It doesn't have any fixed value like my previous signal. It is having more values. It is not having fixed values along the y-axis. Therefore, it is continuous in amplitude because it can take any value which is not fixed along the y-axis. Now, the fourth type of signal is discrete time and discrete amplitude. Now, the signal is discrete in time because it is defined at every instant of time. But it is also discrete in time because along the y-axis, it is taking only two values. One is the positive value plus L and another is the negative value minus L. Therefore, this signal is discrete time and discrete amplitude signal. So here we can conclude that it is not necessary that the signal which is discrete, it will also be digital. Because here we can see that the third signal is discrete signal, but it is not digital because the levels are not fixed for this signal. Now, what is signal processing? Signal processing is the analysis or manipulation of signals like sound, images, time varying measurement values, sensor data, etc. Now, signal processing is always done to extract some information from the signal, and this information is the useful information. Now, there are two types of signal processing. First is analog signal processing and second one is digital signal processing. Now in analog signal processing, as the name says, it refers to the processing of the analog signal, like the signal shown in this figure. Whereas digital signal processing, here we have discrete time signal and the processing of this discrete time signal is carried out to extract some useful information. Now, what is the need of signal processing? First thing, when a signal is transmitted over a channel, there is always a distortion of the signal by external noise. So when we want to recover the original signal, suitable filters are used. So in that case, the signal will be processed. Like I'll take one example. When we are using low pass filter, now this low pass filter, it processes the incoming signal. Now low pass filter will remove the interference of the noise which is present in the useful signal. So in that case, we will be able to recover the original signal from the distorted signal by using the low pass filter. Similarly, the processing of the signal, it helps to estimate characteristics parameters of the signal and also to transform the signal into the desired form. Like I'll take the example of the Fourier transform. Fourier transform is also the method of the signal processing because it will change the time domain signal into the frequency domain signal. And in that case, when a signal is converted into the frequency domain, we can estimate characteristics parameters of the signal like bandwidth, harmonic components, and many other suitable parameters. Now, in signal processing, as we have already discussed, Signal may have to be transformed in order to amplify or filter out any useful information. It can detect patterns. It can prepare the signal to survive a transmission channel. It will prevent interference with other signals which are sharing a medium. It can undo distortions contributed by a transmission channel. It can compensate for sensor deficiencies, and signal processing also find information encoded in a different domain. Now, after signal processing, now we will do what is digital signal processing. As we have already discussed about the digital signal. Now, we have already discussed about signal and digital signal. Now, what is processing on the digital signal? Processing is actually a series operation performed according to some performed instructions. Now, like in this block diagram, we can see that this is a signal input which is analog in nature. Now, first, this analog signal is converted into digital signal by using analog to digital converter. Then it is given to the signal processor, which will perform the processing over the digital signal. Now the processed signal will be obtained. This signal will be given to the digital to analog converter, which will again convert it into analog form. Now this analog signal will be given to audio amplifier, and then it will be given to the destination. Now digital signal processing need to be done so that the information can be displayed, analyzed, or converted to another type that may be of use. Now, in real world, analog products detect signals such as sound, light, temperature, and manipulate them. Analog to digital converter, take these real world signals and turn it into the digital format of ones and zeros. Now, here the processor takes over by capturing the digitized information and process it. Now, this digitized information is then given back for use in the real world. Signals can be compressed. This is also a form of a digital signal processing where signal can be processed so that it can be transmitted quickly and more efficiently from one place to another. Signal can also be enhanced or manipulated to improve the quality that is not or provide information that is not sensed by humans. Like the most commonly used example is in the digital image processing. Now in image processing, the image signal is enhanced so that it is easily sensed by humans and it improves the quality of the signal also. Image signal is also compressed so that it can be transmitted efficiently. Now, all the real world signals can be processed in their analog form, but digital signal processing provides the advantage of high speed and accuracy. Now here we can see one example of signal processing in MP3 audio player. Now during the recording phase, analog signal is input through a receiver or other source. The analog signal is then converted to a digital signal that is in the form of a bits by using an analog to digital converter. And then the signal is given to digital signal processor. Now this digital signal processor performs the MP3 encoding and saves this file to memory. Now during the playback phase, the file will be taken from the memory. It will be again decoded by the digital signal processor and then again converted back to an analog signal through digital to analog converter. Now, so that it can be output through the speaker system. Now, there is one more example of DSP or digital signal processing, that is a low pass filter or digital filtering, which is used to remove noise to obtain a clean digital signal. Now here we can see a noisy signal, that is the signal which is in the form of a distorted signal. Here we can see the effect of the noise which is affecting the integrity of the signal. Now when this signal will be given to the digital filter which is in the form of a low pass filter, it will remove the effect of the noise and will generate a smooth waveform, which is close to the original signal. Now, what is the advantages of digital over analog signal processing? The first advantage is the accuracy. The analog circuit, which are used in analog signal processing, they are prone to temperature and external effects. But the digital filters have no such problem because the digital signal processing can also be performed in the form of a program or an algorithm. And this program or algorithm cannot be affected by temperature or any other external effects. Now, second advantage is the flexibility. Reconfiguration of analog filter is very complex, whereas the digital filters can be reconfigured easily by changing the program coefficient. As I've already told that the digital signal processing can also be performed in the form of a program or an algorithm. If we want to change or if we want to reconfigure our application, then we have only option of changing the program coefficient. We don't have to redesign the hardware component. Now, redesigning of hardware component, which is usually done in analog signal processing, will be costly and time consuming also. Whereas changing the program coefficient or changing the programs or algorithm will also be cheaper, and it will be cost effective, and it will take less time. Now, next is ease of data storage. Digital signals are in the form of a bits 1 or 0, which can be easily stored on magnetic media without loss of fidelity, and it can be processed offline in a remote laboratory. Now, next is time sharing. Digital signal processing allows the sharing of a given processor among a number of signals by time sharing, which will reduce the cost. It is cost effective because here, due to the advancement in the VLSI technology, complex algorithms fits into a single chip. So it will be cost effective. It will reduce the area also. Now, applications of DSP. First thing, the digital signal processing concept is used in image processing. Image is a signal, which is a two-dimensional signal. So when we want to perform image processing, like we want to compress the signal, we want to enhance the signal, in that case, the concept of digital signal processing is used. Then it is used in cellular mobile phones. As we already know that the mobile phones are all digitized. Here we have a communication of digital signal. So the processing of the signal will be using the concept of digital signal processing. Now it is used in communication. Now it is also used in speech and music communication. DSP is also used in biomedical applications. Like we have seen that the condition of the patient, like if we want to check the condition of the heart of a patient, it will be shown in the form of a ECG signal. Now this signal will be processed and the useful information will be retrieved from a signal, and it will signify the condition of the heart of the patient. So in that case, the DSP is very useful in biomedical applications. Now, DSP is also used in radar and sonar, in which the signal is sent to the target and it is received after a certain interval. The signal is processed and then a useful information is recovered. Now, this is all for today's lecture. Thank you.